All right, 8.2, use properties of parallelograms. Some of you guys might already know what a parallelogram is. A parallelogram is a quadrilateral with both pairs of opposite sides congruent. It looks something kind of like this, if you can imagine that these sides were actually parallel. Okay? It doesn't have to be slanted, it could be a rectangle, but basically the opposite sides are parallel to each other. By the way, this little thing here with the parallel sign and then the ogram, this is my abbreviated version of parallelogram. Okay? Alright, theorem 8.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So, if PQRS is a parallelogram, then PQ is congruent to RS and QR is congruent to PS. Also, in a quadrilateral, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So, in this case, if this is a parallelogram, angle P is congruent to angle R because they are opposite each other. Angle Q is congruent to angle S because they are also opposite each other. Alright, let's do an example. Find the values of x and y. FGHJ is a parallelogram because we have opposite sides parallel. So we know that FG, that's the top, has to equal 13 because the opposite sides of a parallelogram are congruent. This is another symbol that means parallelogram. Anytime you see a little slanted box, that means parallelogram. I tend to use this instead when I'm doing notes, but if you're ever doing book work or if you're looking through a textbook, this is another common abbreviation for parallelogram. Alright, actually, you know what? I think they want us to do this. FG equals JH because these are the two opposite sides. FG is x plus 6, JH is 13. So I substituted x plus 6 for FG, and I substituted 13 for JH. If I subtract 6 from both sides, x equals 7. Alright? Now, also, we know the opposite angles are congruent. So the opposite sides are congruent, the opposite angles are congruent. So angle F is congruent to angle H, or the measure of angle F equals the measure of angle H. So Y equals 68. So in this parallelogram, x equals 7, y equals 68. Alright, let's go on to page 2. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now remember, supplementary means they add up to 180, and consecutive means the angles are right next to each other. So this angle and this angle are supplementary. This angle and this angle are supplementary. This angle and this angle, supplementary. And these two. Okay, so these are they're any angles that are consecutive, any angles that are on the same side are supplementary. Okay, so if PQRS is a parallelogram, then x plus y equals 180 degrees. Let's do an example. As shown, a gate contains several parallelograms. Find the measure of angle ADC when the measure of angle DAB, that's this angle, equals 65 degrees. Okay, so we are trying to find ADC, that's this angle, if this angle is 65. Hopefully you guys can see that these two angles are consecutive. And the consecutive angle pairs in a parallelogram are supplementary. So, the measure of angle ADC plus the measure of angle DAB equals 180. Because the measure of angle DAB equals 65, this angle has to be 180 minus 65. 180 minus 65, I think that's 115. Yep, 115 degrees. Alright, I'll let you guys solve for x, y, and z in the checkpoint. Let's go on to page 3. Okay, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Now remember, bisect means it cuts in half. So these diagonals cut each other in half. So this is going to equal this. This is going to equal this. So QM is congruent to MS, and PM is congruent to MR. Okay? Alright, so for example, the diagonals of parallelogram STUV intersect at point W. So they already tell you this is a parallelogram. That means the opposite sides are parallel, the opposite sides are congruent, opposite angles are congruent, all that stuff. By theorem 8.6, the diagonals of a parallelogram bisect each other. So W is the midpoint of diagonals TV and SU. Remember, midpoint is the point right in the middle of a segment. If these bisect each other, then W is the midpoint of this segment, and this segment. So we're going to use the midpoint formula to find W. The coordinates of midpoint W it doesn't matter if you use this one or this one. Let's just use SU because that's what apparently they want us to use. This is 0, 0. And this, let's see here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So this is 6, 5. Now hopefully you guys remember the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. Okay, so I'll make this x1, y1, and I'll make this x2, y2. So I have 0 plus 6 over 2, 0 plus 5 over 2. This becomes 6 over 2 and 5 over 2. 6 divided by 2 is 3. 5 over 2, you could just leave it as a fraction, or you could put 2.5, which is this as a decimal, either way. Alright, I'll let you guys do the checkpoint, and that's all.